Everybody, and this is Leetcode POTD for 13th of January, and I'm Pankaj Sudhar, and happy Lodi to everyone. So this is question number 3453, and this is separate squares first. So it is a medium type of question. So you are given a 2D integer array squares having squares of I means xi, yi, and li. Represent the coordinate of the bottom left point. Which point? Bottom left point, and the side length of a square parallel to the x-axis. Now find the minimum y coordinate. What do we need to find? We have to find the minimum y coordinate value of the horizontal line such that the total area of the squares above the line equals to the total area of the squares below the line. Okay, this is very important part here. That is, answers within the 10 raised to power minus 5 of the actual answer will be accepted. Okay, now I'm giving a very simple example here. As we can see, here is this example. We have two squares. Okay, let me first give you. We are given as xi, we are given as yi, and we are given as li. Okay, what we have to do is first that xi yi is I will show you the constraint also, that then you will see what this actually mean. And if you can see the constraints, that xi will always be greater than 0 and yi is also greater than 0. So both of the xi and yi will be greater than 0. So we can say one thing for sure, that all of the squares that are being formed will be in the only the first quadrant. The first quadrant means this is the first positive quadrant, and here we can say that x is also greater than 0, greater than equals to 0, and y is also greater than equals to 0. So that's the important thing that here this information provides. Okay, let's move to the next important information. This question is devising. Okay, the first part is, let's say there is this line that I am building, that is a y is equal to 1. The squares that are above it having some area, let's say this area, and the squares that are below it having some area. Let's say I write down this area as upward and write down this area as downward. It wants us to find out a line which is parallel to x-axis, which means, let's say I want to draw a line such that the area above the area of the all of the squares above it and all of the squares below it will be equal. So we need to find a such of a line. Now if you can see properly, or if you can see the constraints and everything, I have found one important thing here. One important observation that I have made is that what we need to do is we have to make a function. We have to make a function which will, what it will do, it will take y line means it will take y value means, let's say I'm drawing y is equal to 1, or let's say y is equal to 2. It generally means that if this is my coordinate, y is equal to 1 means this line, y is equal to 2 means this whole complete line. Okay, this is a one way of devising the line when you are studying the math in 11th and 12th, that you will get these kind of questions a lot. Now f of y will do one thing. It will find out the area above y and minus the area below y. And if this f of y is equal to 0, then we can say we have found a line. Woohoo! So this is the main important thing that we are going to find. Now let me give you one more observation from these all points. Let me give you one simple observation, that let's say this is my x and y coordinate, and I think I don't need to draw something like this. We can go for something simply. Let's draw some rectangles and I will show you in a better way. This is my first rectangle, this is my second rectangle, this is my third rectangle, and let's say this is my fourth, fifth, and sixth. There can be okay, I have to delete this. Okay, this is my next rectangle and this rectangle. Okay, now what our main goal is to find a line such that such that the area above, which means the area above this part of area, will be equal to this part of area. These two area, when they are equal, then we will say that we have find a line. So now I think you have understood this question. But can you feel one thing, that the position of xi coordinate means, let's say I have one square positioned at here, that is this bottom left corner is positioned at x1 y1, And let's say I have one another square that is positioned as at position at x2 and y2. If I will see it correctly, if I have to find the answer of yi only, so I can see that this line doesn't check that x2, what is x2. Okay, so x, the value of x1 x2 is not that relevant for us. So what we are going to do is that first we let's understand this problem in this way, that let if I will just put all of these squares, all of the squares that are going to in this first quadrant to be in the leftmost side. So what it means, let I just put this square at this point. I will put this square, the another square at this point. Let's say I have another square on some random point in the first quadrant. I will just do what one thing. I will take the x coordinate as 0 only, and I will just write the y and y values. So you can figure out that the bottommost value, the yi that is given, will be this bottom value. This is y1, this is y2, and this is y3, and the height is defined by the value l given in the squares matrix or squares array. Now you can understand this question properly. So what we are going to do is we are going to use the binary search in this question. We are going to use the binary search in this question. Let me use a very simple page, and what we are going to do, let's say I have values from y is equal to 0 that because it is the constraint that is given, and let's say I will traverse through all of the array, and let's say I have values something like this 1 2 3, 1 comma 2 comma 3, and I have some values like let's take it 3 4 7. Let's take it a value as 8 8 3 and 2. Let's take more values as 9 10 and 15. Okay, if you can see correctly, we are not you know, the first position or the xi, this is xi, this is yi, and the third is li is the length of the squares, or the side of the side length of the square. So what I found is the value of xi is not relevant for us in this question. So what I will do is I can see clearly the y value. I will find the range of y from y is equal to 0 is the bottomest range, and I want to find the maximum range that it can go. So if you can see clearly, if I will draw this square, it will be 1 comma 2, and it will have a side length of 3. Okay, so it's clearly 3 3 3 and 3. Next point is 3 4. Let's say I have this point 3 4 somewhere else, let's say at this point, and I will have the maximum height will be 4 plus 7. Yes, because 4 is the bottomest point, and what, yes, and I will add 7 to it. And the third point is 3 8 comma 3. 8 will be something like this, and 3 here, and it will be something like this part. And the next part is 9 comma 10. Let's say 9 here, let's say 9 and 10 here, and we are moving 15 upward. If you see clearly, the maximum y maximum will be 10 plus 15. Okay, 10 plus 15. So what I will do is first I will iterate through the array, and I will find my y max. Okay, this is my first approach, this is my first part of the solution. And the second part is I will make a binary search. I will take a binary search binary search from from y is equal to 0, from y is equal to 0 to y is equal to y max. Is this understood? I think it's a fairly simple thing. So what this question will do is what this question will do is let's say this is my y is equal to 0, and this is my y max. Okay, at some point, okay, you guys know the binary search, and binary search will do is 0 to y max, and it will find some midpoint. Now the midpoint, let's say, come at this point. So what I will do is I will check in the whole array, and I will find out the area in the upward side. Area I will find the area of upward. I will find the area of downward, and I will find the area upward, I will find that area downward. and I will check if these two areas are equal, then this is our line. That's it. So what I will do is, first we have done as binary search, so our steps will be something like this. We will find y is equal to 0. We will set y is equal to 0 and y is equal to y max. Okay, we have found two things. Then what we'll do, we'll do the binary search on this range 0 to y max. We will find our midpoint, and then this is the main part, that we will check if this midpoint, or if y is equal to mid satisfies our condition. Okay, satisfies our condition. And that's a very simple and very important part here. Now, and if let's say it is satisfying our condition, then we will go for this mid, and else we will go to the further binary search. Now the important part is, you have understood this part. This is very fairly easy part. You will iterate through the array, and you will go through it. But the second part here, the binary search is again a simple thing, but finding the mid and then finding the upward area and the downward area is the real issue. So what I will do, so I will show you how, or what is the approach that I am putting in my solution. Okay, so what I have done is, let's say I have found this as y, this mid is, this currently is my mid. Okay, there will be some squares will be cutting through it. There will be some squares which will be above it, and there will be some uh, squares below it. Okay, this is a simple thing. So what I will do is, I will iterate through my array. Iterate I will iterate through array. What is the array name? Array squares. I will iterate through the squares. Then what I will do, I will check the top and the bottom of the this square. I will check the top and bottom. So bottom will be yi, and the top will be yi plus li. Is it clear to everyone? Because this is my yi. Okay, this line is my yi, and this side has the length of li. So this point will be yi plus li. I think this is fairly simple. Yep. So I have got two things from each squares. Okay. Then I will check if then I will check that if if my mid if my mid is greater than if my mid is greater than top. If my mid is greater than, it means, let's say we are talking about this rectangle. Why? Because if mid is greater than top, it means that we are the our line, the mid line that we have found out, it is above the top of this square. So we can say that we will add we will add it to add this area add this area to bottom area. hmm? ठीक है. The second condition is, hmm, and the second condition is, if mid is if mid is less than if mid is less than bottom if mid is less than bottom, what we will do? If mid is less than bottom, it means we are talking about this square. It means we are talking about this square, because the bottom is this and mid are and so mid is less than the bottom. So I will add to add to upward area. We'll add it to upward area. Now what is the condition for else condition, कि इसके अलावा कुछ हुआ तो क्या करेंगे? Then we will talk about this part. Yes, so in else condition we will take this area alag se. We will take this area differently, and the second area, that is this part area, to different part. And how are we going to collect it? We will going to be a very simple approach. This area will be equal to mid minus bottom, multiplied by length. And top this area will be top minus mid multiplied by multiplied by length, multiplied by length. How? This is the length and this is top minus mid. So it is a rectangle length cross breadth. Similarly, this is a length and this is mid minus bottom. Okay, and we will add this area to the bottom part and this area to the different part. Okay, so now you have understood the whole ideology that we are going to use. But still, in this question, there are some important things. First is we are using the double method here. We are using the double method, and it is saying that the answer that is nearby, or we have found a y which is 10 raised to power minus 5 times accurate, or 10 raised to power minus 5 decimal accurate. We are going to answer this y. Okay, so you will you will get multiple questions. You will get multiple questions when there will be a double entry. There will be double values, and values, double values. Double values means the decimal values. Okay, decimal values, and we have to do a binary search. Now in binary search we know that if the simple condition of binary search is we are going to find the mid. If mid is equal, then it's the condition is satisfied. If mid is greater than x, then what we will do, we will take the r value as mid minus 1, and if mid is less than x, then we will take l is equal to mid plus 1. But if you see correctly, we are adding plus 1 and minus 1. This whole thing will differentiate, or it will take a lot of answers. Let's say we have answer at 1.37765. This is our line point because it's a 10 raised to power minus 5 decimal point na? So it should be this much accurate, but we are losing this point. We are not even going to these values because of this minus 1 and plus 1. So we need something different approach. So what we will do, we will use the precision unit, and generally it is represented by EPS, that we will take as 10 raised to power minus 5. then then what we will do, I will show you in code in a better way. So let's move to the code and then we will understand the answer properly. The first part we have done is the n is equal to squares dot size. We have taken a double L is equal to 0 0.0, R is equal to 0 0.0. For auto, R is equal to, look, I have done this part. I am iterating through the squares, and what I am doing is I am taking the max value of S1. S1, that means the my yi values, that is S1, because 0 index, first index, and 2 second index. First index plus s of 2, that is yi plus li. Okay, so this part is done. Then I have done is epsilon is 1 e raised to power minus 5. Okay, now we are we are not looking at those values ki whenever the l is less than r. What we are going to do is we are finding the difference between the r minus l, and whenever it is greater than EPS, it means, let me show you one more thing. Let's say we are on a number line. We are on a number line, and whenever our here is L, here is R, and let's say they are coming like the mid is coming downwards. So let's say the R is moving towards this direction. It's in the next direction. The L has moved to the next point. The after some point it is moving. L and R are coming closely, and at the same point they have taken a very small space, but they are not going to match. So what we are taking the difference of L and R. We are taking the difference of R minus L, and we are looking at ki if this difference is less than 10 raised to power minus 5. If difference is less than 10 raised to power minus 5, then we will say ki L is equal to R हो गया है. This is a very important part in these kind of binary search operations. Okay, let's get back to the this code part. That is, while r minus l is greater than EPS, first we are finding the double mid for making this whole l plus r divided by 2.0. 2.0 is because l lu and r value are the double values. Then double d is the difference of area of squares, and then mid. Again, what I have done to find the difference in area, squares and mid. So this is my code for finding the difference area. This is my up and this is down. Again I am moving to the squares as q defined. I am iterating to the squares. I'm taking the base value s1. I'm taking the length of the that square is s2. The top will be defined as base plus l, and the base is defined as s1. So the total area of this square will be l cross l. But if this base is greater than equals to y, it means it should come in the which part? It should come in the up part. Okay, अगर इसको if I will show you again this condition that we have devised, it simply says that if y is greater than base, if y is, if you can see the code, it says if the base is greater than y. Okay, okay, what it says, if base is greater than y, it means that I am looking as at this point, and this is my line, and we are talking about these kind of squares. So it will be added in which part? Up part. Okay, so what we have done is we have added it to the up part, up area, upper area. And else if the top is less than y, again I have already told you about this condition also, that whenever the top is this top, this is the top of this square, and top is greater than top is less than y or the mid part, then we will add it to the bottom part or the down area. But else down will be added to l into y minus base, and up plus l into top minus y, and we will return the difference. We will return the difference up minus down. Okay, now let's say we have found the this area. This difference between the area, this diff area function, it can return three types of things. It can return this d can be positive, this d can be negative, or d can be zero. It can be positive when, it will be positive when the upward area is greater than the down area. First part is clear. And it will be negative when downward area is greater than the upward area, and when both are equal, then we can say it will show us 0. But when we go to this part with, if d is greater than 0, then we have taken the l is equal to mid part, else r is equal to mid part. And if you see correctly, we we don't we didn't do this part as l is equal to mid plus 1 or l is equal to mid plus 0.0001. No, we are finding the difference between r minus l, and we are looking at the value. If this value is less than eps value, then we will say that okay, we can move out of this while loop. Okay, and then finally we will be finding some l and r value will be, which is so close that their difference, the difference between l and r will be less than this 1 e raised to power minus 5, and whenever this come we will return it as l plus r divided by 2.0. Why? Because l plus r is the left and right values, and we are finding the mid part. Okay, so if I will submit this part, and you will see, yep, we have all our test cases are passed, and yep, we are doing good. So I hope you have understood this question. This question involves a lot of geography, sorry, geometry, and a lot of coordinate geometry is coming in this part, and I think you got the point, all of the point properly. So I'm just going to give you some basic recap of this question. So we were trying to find the a line, a y line, such that the area in the upper squares, area in the bottom squares will be equal. So and it says that the area can be in the double value, and it says that the precision will be 10 raised to power minus 5. That means if uh, we can find it up to the correct of 10 raised to power minus 5. So generally, whenever this type of question, you can take the EPS value is 1 raised to power minus 6 for standard. If we are talking about the safer side, one we generally take it 1 e raised to power minus 7, and we also take it to very high precision. Then we take it 1 e minus 1. That means this means 10 raised to power minus 1, this means 10 raised to power minus 8, this means 10 raised to power minus 7. Okay, let's generally take this value for we have taken 10 raised to power minus 5 for our equation. And again, what is the difference between this kind of binary search and the different the floating style of binary search? In this kind we are doing just plus 1 and minus 1. But whenever we are going to the this floating style of binary search, we can't do these kind of things. We can't add this mid plus 1, or we can't do mid minus 1, because it will lose a lot of between value in between values, that is decimal values, and which may be our solution. So what generally we will do is this kind of approach that we apply, that is we will take r minus l is greater than eps. That means whenever the difference between the minus l is greater than eps, we will be in the loop double mid. We will find the double mid, and if the function can be very different, it can be applied for, it is a general approach that we can apply. If function of mid is greater than 0, that means we need to make the l is equal to mid, else r is equal to mid part. Okay, and I think, yep, this whole explanation is quite long for this question, and you will get a lot of understanding. I think, I hope you have got a lot of understanding by this solution. And yep, let's meet in the next video. Happy Lodi, happy Makar Sankranti. Woohoo.